So in Chapter P, Section 3 now, we're going to do a ton of examples on multiplying polynomials and special products. Okay, so special products are patterns, and some of them I think are super important, and some of them I think you can just do it the long way, and I'll kind of go over it. So the first thing we want to talk about here is adding and subtracting polynomials. And so when you're adding and subtracting polynomials, even though we've done this in some of the prior videos, we just want to make sure that we actually talk about what does that mean. And what it means is you can only add and subtract polynomials when you're basically adding and subtracting like terms. So what is a like term? So for example, x and 2x are like terms. P squared and 3p squared are like terms. AB cubed or maybe 4ab cubed and 5ab cubed are like terms. And so as you can see in the pattern, what we're talking about when we talk about like terms, notice that the variables are the same and the powers that they're raised to are the same. So the p is squared, the p is squared. A to the first b cubed, a to the first b cubed. The coefficients in front of these variables don't have to be the same for them to be like terms. So when I go to, let's say, add these, I've got x plus 2x, it's going to be 3x. Notice I add the coefficients, and the like term, the x to the first power, stays x to the first power. When I do p squared plus 3p squared, again, that's 1 and 3 is 4, and the p squared ends up in the final answer. If, let's say, I'm subtracting 4ab cubed minus 5ab cubed, again, it's 4 minus 5 is -1, and then ab cubed is in my final answer. So again, the coefficients get added and subtracted, but they have nothing to do with whether or not they're like terms. It's the variables and the powers that determine if it's like terms. So when we're doing problems with adding, binomials and binomials or trinomials and trinomials, it doesn't really matter how many terms there are. The process is the same over and over and over again. What you're going to do is you're going to seek out in all the problems, you're going to seek out the like terms, and you're going to combine those. Now, you don't really need parentheses when you are adding. Notice I'm adding the binomial on the left to the binomial on the right. It's really kind of like I'm distributing a positive to everything, but again, distributing a positive doesn't change anything. So I can even rewrite this as, 4y squared minus 3 plus -7y squared plus 9. And so I can just seek out my like terms, and I know that 4y squared and -y squared or -7y squared are like terms. 4 plus -7 is -3y squared, and then I go to -3 and +9, and that adds up to a +6. And so this is the final answer. So that's just, it's that easy. You don't have to rewrite it like I did. I do like to rewrite it. I like to get them out of the parentheses. But if you don't, you can just, again, it's a plus, so everything stays as it is, and you just start finding your like terms. So I see my highest exponent is 3. So 5x cubed, and I find another x cubed, and that's going to be 6x cubed. Then I go to minus 7x squared, and I find its like term, which is 2x squared, and that's going to be minus 5x squared. Then I go to my minus x here, which doesn't have any other like terms like it, so it's just minus x. And then the last one is minus 3 and a +8, which is +5. And so that would be my final answer. Again, keeping my variables the same. X to the third is still going to be x to the third. I only change the coefficients. Now, the tricky one comes in when you have a minus involved here. When you're subtracting a polynomial from another polynomial, you have to be careful because you're not subtracting just the first term from the original. You're subtracting everything. So this minus in the middle is sort of like, I treat it like a -1, and I say, okay, it's like I'm distributing the -1 to everything, and so I rewrite it. So again, the first stuff stays the same. 2x squared plus 1, no problem. But then this, after the minus, I have to distribute that minus to every term. So instead of positive x squared, it's going to be minus x squared. Then I'm going to do -1 times minus 2x, which is plus 2x, and -1 times positive 1, which is -1. And so once I've distributed that minus, now I can start again by trying to combine my like terms. So 2x squared and minus 1x squared is a positive 1x squared. Then I have positive 2x here, no other x's, so positive 2x. And then I have plus 1 and minus 1, which end up canceling out. And so this is my final answer. So the minuses are where I think you have to be very, very careful. So here, notice I have this problem, number 4, and I'm subtracting a lot from that other 1. So again, I'm going to start out, I'm just going to rewrite this, 7x to the 4th minus, and sometimes I do a 1x, like minus 1x squared minus 4x plus 2. And now I'm going to subtract everything over here. Now, one method that I do, and sometimes I find it helpful, again, you can do it all linear, like you can do minus 3x to the 4th. This is going to become plus 4x squared, and this is going to be minus 3x. And you can seek out your like terms from there. However, I like to do them at this point. I kind of like to put them in columns, and I'll show you what I mean. When I do minus 3x to the 4th power, I like to write the 3x to the 4th underneath the one above it. So minus 3x to the 4th. Notice I kind of put my like terms in columns. This is just something that I like to do. It is not required, but I find it helpful. So then when I do minus -4x, I know that that's going to be plus 4x squared, right? Instead of a minus 4x squared, it's a plus 4x squared. And instead of this being a plus 3x, it's going to be a minus 3x. And so again, it's minus 3x here. And so now I'm just basically able to combine my like terms, and now I can just do 7x to the 4th minus 3x to the 4th is 4x to the 4th. A minus 1x squared and a plus 4x squared is a plus 3x squared. And a minus 4x and a minus 3x is a minus 7x plus 2. So again, 4x to the 4th plus 3x squared minus 7x plus 2. And doing them as a column like that kind of helps me sometimes. Again, it's not necessary, but I find it helpful. So of course in this example, we go from like the most basic kind to like more and more intricate. So you just have to take your time. Notice the first one is y cubed plus 1. That's fine. And then you have minus this entire expression here, right? So let's at least kind of get that expression. Let's get it combined if we can, and let's simplify those a little bit. So I'm going to keep the minus on the outside here, and I'm going to work with inside the bracket. And inside the bracket, notice that you have y squared plus 1 plus 3y minus 7. So y squared plus 1 plus 3y minus 7. And again, let's just kind of see what do we have here that we can join together. So we've got y squared doesn't have a like term, plus 3y doesn't have another like term, but plus 1 and minus 7 can combine to minus 6. Now I think I'm ready to kind of distribute the minus to all the different terms, right? So it's going to be y cubed plus 1, and then I'm going to have minus y squared minus 3y plus 6. And so again, now I'm looking for my like terms so I can combine them all together with my answer. So y cubed, there's no other y cubed, so there's no other like terms. I've got minus y squared, no other like terms for that. I've got minus 3y, no other like terms for that, and I have plus 1 and plus 6, which is plus 7. And so there you have your final answer. And again, you just can't keep going. Once you don't have any like terms, once, they go in the list. So there's, 4 terms in this list. I can't combine them any further because they're not the same. So when I'm multiplying, the beauty of multiplication is they don't have to be like terms to be multiplied together, right? I can multiply anything together. When I do, I take my numbers, my coefficients, and I multiply those together. And then I take my variables, and remember, when you multiply variables, you just add the exponents. So there's different tricks and tips depending on how many terms you're multiplying. Once you multiply everything out, then what's left over, all those products, then you combine your like terms at the end. So for example here, notice that I've got x times a trinomial. I have a monomial out here times a trinomial. And so I'm just going to apply the distributive property here, and I'm going to do x times 3x squared is 3x cubed. X times negative x is minus x squared. And x times positive 1 is plus 1x or plus x. And that's my answer. So that's the trick to it. None of those terms are like terms, so I can't combine them any further. And I'm done with that multiplication problem. Again, here I have a monomial times a binomial. Again, anytime I have a situation where I have something times something else like this, I'm going to apply the distributive property. So I'm going to do negative 3x times 5x is minus 15x squared. And minus 3x times 2 is going to be minus 6x. Notice I'm multiplying the numbers, minus the coefficients. Minus 3 times positive 5 is minus 15. And minus 3 times 2 is minus 6. And again, now I'm just done because I can't combine any other terms there. In number 8, again, it's another monomial times a trinomial, so I'm going to be using the distributive property here. So it's going to be 4y to the 4th power plus 2y to the 3rd power minus 3y squared. And again, all my variables have a different exponent, so I have no like terms, and so that's as far down as I can go. And then the last one, notice it's a monomial times a binomial. It's just in a different order. The monomial is here in the back. So again, same thing. I'm going to do distribute it. So it's going to be 2y cubed times 2 is 4y cubed. And 2y cubed times negative 3y is going to be minus 6y to the 4th power. Now, I'm not going to lie. Honestly, if I had this problem, I probably would have rewritten it at a minimum to just have put the entire monomial in the front, just because I feel more comfortable with it in the front. And I still would have gotten 4y cubed and a minus 6y to the 4th. That doesn't matter. It doesn't matter if the minus 6y to the 4th came in the front and the plus 4y cubed came after. It's the same answer. It's just, I don't know, I would have liked to have put it in the front just because it's more the way I like it, I guess, more of my style. So now these become a little bit more complex because if you notice, it's a binomial times a binomial. So what's really happening is that this is a double distributive property problem. I'm basically taking the first term, which is this x, and I'm going to multiply both terms in the other, in the binomial. So it's going to be x times x is x squared. X times positive 4 is plus 4x. And then I'm going to take the minus 8, and I'm going to do the same thing. I'm going to do minus 8 times x, and minus 8 times 4 is minus 32. And I'm going to look to see, does my answer have any like terms that I can combine further? And it does. 4x and negative 8x can combine because they're like terms. And so this is the solution to that product. So there's a shortcut to this. It's not really a shortcut, but it's a way of remembering to multiply everything. See, I distributed the x to the x and to the 4, okay? And I distributed the minus 8 to the x and the 4. Well, there's a pattern called FOIL that kind of reminds you about that. And it says, okay, you multiply the first number of one binomial, so first times first, to the first number of the second binomial. So that's x and x. And then the second one says the outer term times the outer term. So again, it's the outer term of the first binomial to the outer term of the second. So this is first times first. And this is outer times outer. Notice it's the outer edges, okay? Then the I represents inner times inner. So that means the inner term times the inner term. So that's where we got this minus 8x. And then the L stands for the last term times the last term. So last times last. I don't even have the right term, right? And that's the negative 8 times the 4. So this here was the F, this is the O, this was the I, and this was the L. And it's just a reminder so you don't leave a step out. However, again, if you just see it as a double distributive property, it's the same thing. So let's try to do this number 11, thinking of in terms of FOIL. So first times first, 3x times 5x is 15x squared. Outer times outer, 3x times positive 7 is plus 21x. Inner times inner, minus 10x. And last times last is minus 14. Again, usually it's the middle terms that are like in these. Not always, you just double check. But in this case it is. So 21x minus 10x is 11x. And this is my product. Again here, I come over to this one and I start first times first. And I get 2x squared, outer times outer, plus 10x, inner times inner, minus 4x, and last times last, minus 20. Again, I'm going to combine my like terms, which are the 10x and the minus 4x, and I get my product. Now, there's one last method that I'm going to do on this problem here at the end, and again, you can choose your own. You could do distribution. You could think of it as 7x times those two things, and then minus 2x times those two. You can see it as a FOIL problem. And the other way you can do it is you can create an area model, or I like to call it a box method. And I don't think these are incredibly useful for a 2x2, meaning a binomial times a binomial. But I do tell you that I do like it when it's a binomial times a trinomial, or two trinomials times each other. I find this very neat. And what you do is you write each one, like 7x and a minus 2. And then here you write 4x and a minus 3. This is an exceptionally structured method for those of you that maybe write a little more sloppy, or those of you that kind of forget your negatives. I find that this method is super helpful. So what you do is you write it out. Again, remembering to write your minuses, okay? And then what you do is you multiply each thing and you write the product in the box. So 4x times 7x is 28x squared. And then I'll do 7x and negative 3 is minus 21x. And then I do 4x and negative 2 is minus 8x. And minus 3 times minus 2 is a plus 6. So all my products, just like they are here all in a linear fashion, here they're in this box. And a lot of the times, my like terms are diagonally across from each other. So I basically start with 28x squared. I combine my like terms there from the middle, 29x, and then plus 6. And this is the product. And I find that this method is very organized and very helpful. So at a minimum, you should try it. See if you like it. Now, that box method I just did, that method is my favorite for a problem like number 14. So I'm going to work number 14 out in the box method that I just did in the last slide. And then I'm going to work it out in a more traditional way. Okay, but again, I just want to give you the opportunity to see this method because I do think this method is very helpful. So again, I'm going to start with the first one. It's x squared. It's minus 2x, and it's a positive 2. And then the second term is an x squared, a positive 2x, and a positive 2. Okay? And then I'm going to write my solutions of those products inside. So I've got x to the 4th minus 2x cubed, and I have plus 2x squared. Then I go to the second row, 2x cubed minus 4x squared plus 4x. And then I've got 2x squared minus 4x plus 4. And again, I look at it and you're going to notice that not all the time, but often, your diagonals are going to end up being like terms sometimes. And so I start going through to write my answers. So I start with x to the fourth here. Then I've got 2x cubed and a negative 2x cubed, so these canceled. Then I have a 2x squared plus minus a 4x squared is minus 2x squared, and a plus 2x squared, so these actually all canceled out. A 4x and a 4x, those cancel, negative 4x and 4x canceled out, and then I just have a plus 4. So all that work, and I ended up with this simple little answer. However, I do think that square method is very, very helpful. Now, for those of you that, you don't like the idea of the square method, that's fine. Actually, let me do the next one without using the square method. Let me try using an alternative. So let's say you don't want to use the area model or the box model. Then what you would do is just like you did with the binomials times the binomials, what your goal is to take the first term in the first expression and multiply it by every term in the second expression. So again, 2x squared times x squared is 2x to the fourth. And then you do 2x squared times 3x is 6x cubed. And 2x squared times 2 is plus 4x. So you did the first one. Now you're going to go to the second one, and you're going to do the same thing. So you're going to do minus x times x squared is going to be minus x cubed. Then you have minus x times 3x is minus 3x squared. And minus x times 2 is going to be minus 2x. And then you go to the last one, which is 4 times x squared is 4x squared. 4 times 3x is plus 12x. And 4 times 2 is 8. And so you distributed each term from the first one to each term in the second. And now you're ready to really go through and combine your like terms. So you start with your highest exponent, which is 2x to the fourth. There's no other x to the fourth, so there's nothing to combine it with, so you're done. Then you go to your 6x cubed, and you have minus x cubed and no other x's, so 6 minus 1 is plus 5x cubed, so these are out. Then you go to your squareds. You've got minus 3x squared and a plus 4x squared, so that's a plus 1x squared, so those are done. Then you go to your x's. You got a 4x, a minus 2x, that's 2x, and a 12x is 14x. Let me make that a little neater. So you've got a plus 14x. And so then these cancel, right? And then you have that last plus 8. And so this would be your solution if you did it this way. So again, that's another method you could choose. The only thing that I would have done differently in this second set, let's say, is when I wrote each kind of layer, like I started out with 2x to the fourth plus 6x cubed plus 4x. When I got to that red layer and I had a minus x cubed, I would have written it here. When I had the minus 3x squared, I would have expanded this out a little bit here. This is a little tricky because there were some missing terms, but I would have done the plus 4x there. I would have left a little space, right? And then when I got to the next one and I did the minus 3x squared, and then I would have gotten to the minus 2x. And then when I got to the yellow section and I got the 4x squared, and I had the 12x, and I had the 8, I would have done it more like that. And then I would have done my columns. So I would have had 2x to the fourth, I would have had the 5x cubed, I would have had the plus x squared, and I would have had the 14x and the 8. But I would have done it like this in columns, and so my like terms would have kind of been together, and it wouldn't have been so difficult to kind of find the like terms. So again, different strokes for different folks. You figure out what works for you. For me, anytime there's a trinomial involved, I jump to the box method. I just think it's the cleanest method here.